Hi, I'm Kathy Levinger. In this section we're going to look at quadratic functions. Let's start with a definition. A function that can be put in the form f of x equals ax squared plus bx plus c, where a, b, and c are real numbers and a does not equal 0, is called a quadratic function. This is the form of a quadratic function where specifically a does not equal 0, although b or c could. Another important point here is that the graph of every quadratic function is something called a parabola. Well, let's graph a quadratic function in this way. What we want to do is fill out the table below for the given quadratic function. Then we're going to plot the points to obtain its graph. After we've done that, we're going to label something called the vertex, and we're going to state something called the axis of symmetry. But let's start by taking our quadratic function and filling out the table. What we need to do is put each x into the function and find a corresponding y. So let's start by putting -3 for x, in which case we need to find 2 times -3 squared. -3 squared is 9. 2 times 9 is 18, and I'll put 18 in the table. Now for -2, I need to find 2 times -2 squared, which is 2 times 4, or 8. For -1, I need to find 2 times -1 squared, which is 2 times 1, or 2. For 0, putting 0 for x, 2 times 0 squared is 2 times 0, which is 0. For 1, I need to find 2 times 1 squared, or 2 times 1, which is 2. For 2, I need to find 2 times 2 squared, which is 2 times 4, or 8. And for 3, if you follow this pattern, I need to find 2 times 3 squared, or 2 times 9, which is 18. And so these are the points that I want to plot and come up with the graph of the function. Let's translate them to another piece of paper. We need x values of -3, -2, -1, 0, 1, 2, and 3, y values of 18, 8, 2, 0, 2, 8, and 18, and we're ready to come up with the graph. In a coordinate system, I'm going to plot the point. Here's my x-axis, here's my y-axis. -3, +18. So let's scale our axis by ones, but choose a small size tick mark. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Put 10 here. 11, 12, 13, 14, 15, 16, 17, 18. So -3 corresponds to 18. -2, maybe I should label these so you know what I'm using. -2 is going to correspond to 8. -1 corresponds to 2. 0 to 0. 1, 2, 3. 1 corresponds to 2. 2 to 8. And 3 to 18. And now I need to connect those with a smooth curve, and I'll get the graph of the quadratic function, and that shape is called a parabola. Roughly that shape. Now there were two things that I want to indicate on this graph. Well, one I want to label and one I want to state. The thing that I want to label on the graph is the vertex. The point 0, 0, this point, is the vertex of the parabola. It's either the minimum, as in this case, or a maximum if the parabola happened to open down. The other thing I want to state is something called the axis of symmetry. whoops, if I could spell it correctly, the axis of symmetry. The axis of symmetry is, for a quadratic function, a vertical line that runs through the vertex. In this case, the axis of symmetry is exactly the y-axis. Its equation is x equals 0. Well, let's look at another example. For the quadratic function shown below, we're going to use a calculator to fill out the table and then estimate the vertex and axis of symmetry by looking at the table data. We're going to try to make an estimate of the vertex and axis of symmetry. Then we're going to sketch the graph with the help of a calculator and verify our results. So our quadratic function is f of x equals negative 3/4 x squared minus 7x plus 2. And our first item in our table is negative 5, our first x value. Grabbing a calculator at home screen, we're going to enter negative 3/4 times negative 5 squared. So parentheses negative 3 divided by 4, close parentheses, open a new set, negative 5 squared, then minus 7 times negative 5. Try to figure out a way. There, now you can see both. Minus 7 times negative 5, and then plus an additional 2. Pushing enter, I see that that value is 18.25, and I can write that in my table. Now I want to do that for negative 4.8. So I want to find negative 3 divided by 4, close parentheses, times negative 4.8, close parentheses, squared, minus 7 times negative 4.8, close parentheses, plus 2, and I end up with 18.32. A little bit more than I just found. Using negative 4.7, here's a little trick that you might try on your calculator. The calculation I just made is stored on a TI calculator like this one. If I push second and the enter button, it pulls my previous calculation into an active status. And let me zoom in and show you how that looks. What that looks like is negative 3/4 times the negative 4.8 squared minus 7 times negative 4.8 plus 2. The cursor is right next to it, and I haven't pushed enter, so I'm going to go up with my arrow key and make the negative 4.8 a negative 4.7. Then I'll go down to the other negative 4.8, make it a 4.7, then push enter, and I see that that's 18.3325. And I want to put that in my table. So let's go put that in the table. 18.3325. The next value I want to use is negative 4.5. So let's push second enter and change the negative 4.7 to a negative 4.5. And we get 18.3125. We need to write that in our table. So we need to put in 18.3125. And finally, we want to use negative 4. So let's push second enter and highlight the negative 4.5 and delete the 0.5 part. And same for the other 4.5. And we get the number 18 to put in our table. Now my table's a little bit crowded. Maybe I'll zoom in so you can see the numbers I have written there. We need to examine them a little bit because we're supposed to estimate the vertex and axis of symmetry from the table data. So looking at the table data, I can see that it ranges from 18.25, goes up a little to 18.32, up a little more to 18.33, then down again to 18.31, and then down further. So the vertex is around negative 4.7, but maybe not quite at negative 4.7. I would say it's a little bit between, well, between negative 4.7 and negative 4.5. So let's put the vertex at approximately negative 4. Let's say 6 and 18.34, maybe slightly bigger than 18.33. The axis of symmetry, if this is my chosen vertex, oh, I need to zoom out so you can see that. There's the vertex. The axis of symmetry, if this is my chosen vertex, has to correspond to the x coordinate of the vertex. And we'll say x is approximately negative 4.6. Well, let's see how good we were at estimating by actually graphing the calculator, graphing the quadratic function using your calculator. So this time what we're going to enter is in y equals, we're going to enter parentheses negative 3 divided by 4, close that, x squared minus 7x plus 2. So I have the function entered as y1. Let me let you look at that. And now we need to think about what kind of window we might want to use to come up with the graph. Now the table data was between negative 5 and negative 4, so an x-min of negative 10 might be okay, but we may not need an x-max of 10 if the vertex is somewhere around negative 4.6. So let's make our x-max 2, choosing a sort of arbitrary number there. A y-min of negative 2 might be okay. Our vertex looked like it had a value of 18 and a little bit, so 20 might be all right. We might want to go just a little bit bigger than that to see the vertex a little more clearly. But again, that's an arbitrary choice. Let's put graph and push graph and see how well we chose. And that's not a bad graph of the quadratic function. We can see things of interest like the vertex. And once we identify the vertex, we can write down the axis of symmetry. Well, there's some really neat calculator options that will allow us to find the vertex. One of them is we could zoom in. So let me show you how to do that. Choose the button called Zoom on your calculator and option 2. What that does is puts a blinking cursor on your keypad. It's not sitting at the point to which I want to zoom in, so I'm going to use my arrow keys to move that cursor close to the vertex, since that's the point at which I want to zoom in. Once the cursor is where you're interested in zooming in, you can push enter on your calculator, and the calculator will redraw the graph using the cursor as the center of the screen. And then you have the option of adjusting your cursor and pushing enter again because you're in zoom in mode. So I've zoomed in twice, and it looks like my cursor is roughly in the center of that set of horizontal pixels. They're not actually horizontal. It's just the calculator's attempt to draw that piece of the parabola. And notice that the cursor is at negative 4.66, actually, 18.32. Well, we estimated our vertex to be very close to that, and this confirms our estimate. Before we leave the calculator, though, I'd like to show you another option. It works better if we go back to the window we had set originally. So I've just pushed the window button. You can see that I did zoom in, and the calculator adjusted the screen accordingly. Our window was negative 10, 2 in the x direction, and it was something like negative 2, 22 in the y direction. And that gets us back to our starting point. Another option you might use to find a vertex of a parabola is an option called maximum or minimum, in this case maximum. It's found under calc, so we'll push second calc and choose option 4, which is called maximum. The calculator is asking for you to enter on a left bound of the maximum point. So using your arrow key, move to the left of the vertex and push enter. Now it would like a right bound, so using your arrow key, move to the right and push enter. Notice that it puts little darkened arrows on the screen to indicate that you have bounded that vertex. The calculator is asking, is this a good guess? You could adjust the guess with your arrow keys or push enter, and it'll run a program that will find the maximum at negative 4.66666, 18.33, which is what we found when we estimated by hand. Well, we should write the vertex and axis of symmetry, or at least confirm what we found on our paper as this. So let's go back to the problem. We had written the vertex was approximately negative 4.618.34. That's very close to what we found by hand. And the axis of symmetry is x is approximately negative 4.6. All that fits very nicely. Well, let's try one more problem. Here we're given the height of an object thrown vertically upward with a velocity of 12 feet per second from ground level as a function of time in seconds is given by f of t equals negative 16t squared plus 12t, where f is the height of the object in feet at time t, and remember that t is time in seconds. The first thing we want to do is find the height of the object at 0.2 seconds. What that requires us to do is use function notation and find f of 0.2, which is negative 16 times 0.2 squared plus 12 times 0.2. Well, using a calculator, we can find negative 16 times 0.2 squared plus 12 times 0.2, and we end up with 1.76. The height is in feet, and so the object's height in feet is 1.76 feet after 0.2 seconds. Well, here's another question involving that same function. What we want to do here is sketch a graph of the height of the object as a function of time. And what we have is f of t equals negative 16t squared plus 12t. Let's use our calculator to help and enter that function in y equals. We're going to enter negative 16x squared, remember you can't enter t's, plus 12x. And we need to think about what kind of window might be appropriate. T or x on the calculator is time. We don't need any negative time, so a good x min is 0. Now we found that after just a real short time, 0.2 seconds, the height of the object was 1.76 feet. So we won't need a large x max. Let's leave 2. We have 2 on our screen, and that should be plenty of time values. As far as a y min, the height of the object won't be negative unless it goes underground, so we could put y min to 0. Now the maximum height of the object we found was 1.76 feet after 0.2 seconds, but it probably goes up a little bit more than that, but maybe not 22 feet. So let's put something like 5 feet in for the height and push the graph button on the calculator. We get a graph, and I'll zoom in, and that's the graph that we want to draw. Now notice the tick marks on the axis. In the x direction I left the scale of 1, so there's 1 second, there's 2 seconds. In the y direction I left the scale at 1, and so there's 1, 2, 3 feet, 4, 5 feet. And this is the graph that we want to translate to our paper. So let's see. Noticing those few pieces of information, we can sketch a graph with this as 1 second and 1, 2, 3 feet, here's our feet, is more than enough, and we can do something like a rough sketch of the graph. Now what we want to do is, on our graph, find the maximum height the object reaches and the time it takes to reach that height. What that means is find the vertex. Well, let's use that maximum option on the calculator. Here's our graph. We're going to choose second calc, option 4, and now I need to go to the left of my maximum point. I can see the X is changing at the bottom of the screen, and there's my cursor. Move a little bit to the left and push enter, a little bit to the right and push enter, and I can adjust a little bit with my arrow keys or push enter to use the calculator's guess. And I see that the maximum is about 0.37 to 0.25. Well, let's write that down and think about what it means in terms of this problem. 0.37 to 0.25. So what we found was the vertex was 0.37 approximately to 0.25. The question says find the maximum height and the time it takes to reach that height. Remember that the independent variable is time in our problem, and that the dependent variable represents the height. So the maximum height is the 2.25 feet, and the time it takes to get there is approximately, because we rounded, 0.37 seconds. Now on our graph, we want to find the time it takes for the object to reach the ground. Now, if you look at the graph we've sketched, that point is where it hits the horizontal axis. So let's go back to our graph on our graphing calculator, and let's use our zoom in option to find the point where the graph hits the horizontal axis. We choose zoom and option 2, and we want to move the cursor with the arrow key to the right and down and close to the point where the curve hits the axis. Now it's buried behind the X number here, but I can push enter and the graph will be redrawn. And let me adjust the cursor and enter one more time to zoom in one more time. Again, I'll adjust the cursor a little bit and see that the numbers at the bottom of the screen are 0.7486 and this 1e negative 10, which is the calculator's version of scientific notation. For all practical purposes, that number is 0. It's 1 times 10 to the negative 10th power. So consider that 0. And note that the X value where the cursor is about 0.75. Well, let's translate that back to our problem. And we can say that the time it takes the object to reach the ground is approximately 0.75 seconds. Well, in this lesson we've looked at quadratic functions. Be sure to work some problems from your book to practice this.